Hi everybody and welcome. So today we are going to have a practice question session wherein we are going to discuss the questions from the kinetics of different order reactions, which comes under the module of chemical kinetics. Now, anybody who is actively preparing for CSIR NET, GATE, BARC, or TIFR are encouraged to practice more and more problems. And this video is going to help you sort the problems section-wise and also improve your problem-solving skills. Okay, so without any further delay, let's start with our question. So the first question is, the combustion of ethane can be represented by this equation 2C2H6 plus 7O2 gives 4 carbon dioxide plus 6 water. And they have asked which of the following is true. The rate of combustion of ethane is 7 times faster than that of rate of consumption of oxygen. Water is formed at a rate equal to 2 by 3 times of rate of formation of CO2. Rate of consumption of oxygen is equal to rate of formation of water, and carbon dioxide is formed twice as fast as ethane is consumed. So if we look at the options, we can see that all the options are related to combustion, consumption, rate of formation, etc. So with whatever is given, let's try and write the rate of the reaction first. Okay, so what is the equation given? It is 2C2H6 plus 7O2 giving 4CO2 plus 6 water. If we write the rate of the equation, we know that rates of the equations are changes in concentration of a species with time. Correct. So this is going to be change in the concentration of ethane with time into, you have to take the reciprocal of the stoichiometric coefficient as well. So this is going to be 1 by 2 into d concentration changes of ethane by dt, which is equal to minus 1 by 7 dO2 by dt, which is equal to plus 1 by 4 dCO2 by dt, and that is equal to plus 1 by 6 dH2O by dt. Okay, so this is how you represent the rates of the reaction. Again, remember, you always put a negative sign in front of the species which are being consumed. So here C2H6 and O2 are being consumed. Hence, there will be a negative sign in front of those species, while carbon dioxide and water being formed will be put plus signs as it is being formed. All right, now let's see what the reaction or what are the options. Rate of combustion of ethane is 7 times that of oxygen. So the option A is relating ethane and oxygen. So minus 1 by 2 dC2H6 by dt is actually equal to 1 by 4. No, it's relating oxygen. Okay. Is equal to minus 1 by 7 dO2 by dt. Minus minus gets cancelled. If you take 2 to the other side, it becomes 2 by 7 times. So that is not true. It said that it is 7 times faster, but then you're not going to get the same thing even if you rearrange. So that is not true. Option B. Option B is relating water and carbon dioxide. Relating water and carbon dioxide. So it says that water is formed. So how is water formed? Water formation is dH2O by dt. And how is it related to carbon dioxide? You can take 6 to the other side and it becomes 6 by 4 dCO2 by dt. Correct? So this says rate of formation of water is equal to 2 by 3 times rate of formation of CO2. So rate of formation of CO2 is here, but it is 3 by 2 times from the calculation that we are doing, but in the options it is given 2 by 3, so that is also wrong. Next, option C, rate of consumption of oxygen is equal to rate of formation of water. That is also not true, because here it is 1 by 7 and on the right hand side we have 1 by 6. So option C is also wrong. A, B, C are cancelled. So the correct option is option D. Option D. Let's see. Carbon dioxide is formed twice as fast as ethane is consumed. So they are asking a relation between carbon dioxide and ethane. So if you take that, minus 1 by 7. No. Minus 1 by 2. It's ethane. Minus 1 by 2 dC2H6 by dt is equal to 1 by 4 times dCO2 by dt. If you rearrange, 4 comes to this side, and what do we get? We get 2 times consumption of ethane is equal to formation of carbon dioxide. And that is what is said. Carbon dioxide is formed twice as fast as ethane is consumed. So the correct answer to this question is option D. Correct answer to this question is option D. All right. This question was asked in TIFR. Next question, a previous year GATE question. So they have given a reaction 2NO plus 2H2 changing to N2 plus 2H2O. The question is, the rate expressions are as shown below, 1, 2, 3, and 4. We have to find the relationships between K, K1, K1 prime, and K1 double prime. Okay, so let's do. So a rate equation is given, 2NO plus 2H2 gives N2 plus 2 water. There is water, the question. All right. Oh, sorry, it's not N2, it's H2. Sorry, it is not H2, it's N2. Yeah. So this is how the equation is given. So from the equation, we can write the expression for the rate of the reaction. It is the reciprocal of the coefficient 1 by 2 minus d NO by dt is equal to minus 1 by 2 dH2 by dt is equal to plus dN2 by dt, and that is equal to plus 1 by 2 dH2 by dt. Very easy. We know how to write the rate expression. Now let's plug in the values, whatever is given. Just a second. N2, okay, it is a hydrogen itself. Sorry, it is hydrogen itself. Yes, okay. Now let's plug in the values. So what is NO? dNO by dt as from expression 2 is this. So let's put the value. So the expression for minus dNO by dt is given. So I'll keep 1 by 2 over here and I'll use the remaining. It is K1 prime NOH2. That is equal to, what is dH2 by dt? Again, I'll keep my 1 by 2 over here because the expression is given for minus dH2 by dt. That is equal to K1 double prime NO into H2. Expression for dN2 by dt is K1 NOH2. And finally, water. 1 by 2 KNOH2. Now from these, I can see that NO and H2s are common. I'll cancel them out. And what do I get? I get, let's say I multiply the whole relation with 2. Because in my options, if I can see, it's not in fractions, it's in whole numbers. So I'll multiply the whole thing by 2. So what do I get? I get K1 prime is equal to K1 double prime is equal to 2K1 equal to K. So the correct option is, I have to get 2K1, this one. K is equal to 2K1 is equal to K1 prime is equal to K1 double prime. The correct answer to this question is option C. Sorry, D. Option D. Option D. Okay. Third question. Now this question should be marked important. Such types of questions are not being asked. This was asked for JEE kind of exams, but then it's a beautiful question that you must practice. Okay, so let's see. A certain amount of 2N2O5 gives 4NO2 plus oxygen. N2O5 is decomposing at 108 mg per liter per second. The rate of production of NO2 is, again in this unit. So what you have to be careful of is, generally, when they give the rate of the reaction, rate of formation, rate of decomposition, etc., the unit of rate is moles per liter per second. Moles per liter per second. But in the question, it is given in mass per liter per second. So a unit conversion is involved over here with which you should be careful. Okay, so let's start the question. Decomposition of N2O5 relating the production of NO2 is what we want. So let's try to relate them. With respect to N2O5, the rate of the reaction with respect to N2O5 is minus 1 by 2 dN2O5 by dt. And with respect to NO2, it is equal to 1 by 4 dNO2 by dt. Now, if I rearrange, what I can say is 2 times, I'll take 4 to the side, 4 by 2 is 2, minus 2 dN2O5 by dt is equal to dNO2 by dt, which means my formation of NO2, correct? This is formation. This is formation. My formation of NO2 is equal to 2 times the disappearance of N2O5, and that is what we have to find numerically. So let's see what's given in the question. In the question, they have given about the decomposition of N2O5 as 108. So decomposition is minus dN2O5 by dt. Understand that when the question is in terms of rate of decomposition, rate of disappearance, rate of consumption, coefficients are not considered. So when it is just decomposition, you don't consider the coefficient, and this is equal to 108 mg per liter per second. Now, as I said, we need to convert the unit. That is a standard unit of rate. How do you convert? How do we convert mass to moles? If you have mass in grams, you have to divide it by the molecular mass. You have to divide it by the molecular mass. Now, what is the molecular mass of N2O5? Nitrogen mass is 14, 14 into 2, 28. Oxygen mass is 16, 16 into 5 is 80. It's 108. Beautiful. 108. Okay. So we need to convert this to grams pehle, first of all. So 108 into grams is equal to 108 into 10 to the power minus 3 grams per liter per second divided by 108 is its weight, correct? Grams per mole. Now, if you can see, grams and grams get cancelled, moles come to the top, and we have got the rate in units of 10 to the power minus 3 moles per liter per second. This is the actual unit of rates with which you have to put in any relations that you have. Okay, so now you got the relation for the disappearance or the unit in the required units of rate. We got the disappearance of N2O5. Now we need to find the appearance of NO2. Appearance of NO2 is equal to how many times? 2 times the disappearance of N2O5. 2 times. So that is equal to 2 into 10 to the power minus 3 moles per liter per second. But what is the question? In the question, they have asked us to change the unit back to mg per liter per second. So how do you change it? If moles, number of moles are given to you and you want to convert it into grams, you multiply it with the molecular mass. What is the molecular mass of NO2? N is 14. Oxygen single unit is 16. 16 into 2 is 32. So when you add, you get 46. 46. So you have to multiply, correct? So when you multiply, you get it in grams. And if you have to convert further to mg, grams to mg is into 1000. So to convert, you will multiply this with the molecular mass, which is 46, into, you have to convert grams to mg into 1000. Already there is 10 to the power minus 3. And after conversion, instead of getting moles, you will get grams per liter per second. The reverse of what we did over here. It's just the reverse of what we did over here. Okay, 10 to the power minus 3, 10 to the power plus 3 gets cancelled. 2 into 46 is 92. And the correct answer to this question is 92 mg per liter per second. Again, option A. Indeed. Okay. Next question, a very important question and a favorite type of question for CSIR NET. The question is to find the order of a reaction of the following experimental data given to you. So what is given? There is some reaction whose rate is as expressed. We have to find the values of A and B, which is the order with respect to A2 and B2. Okay, so let's move ahead. It's very easy. If you look at A2 and B2, and if you want to find the rate, we will compare with experiments with initial concentrations of either one of the reactant kept constant. For example, let's say that I compare experiment 2 and experiment 3. Experiment 2 and experiment 3. So when I take experiment 2 and 3, my concentration of B is kept constant, correct? And whatever change I get is only with respect to A2, because my concentration of B is kept constant. Whatever relation I get, that is, my A2 is increasing 2 times, and my rate is also increasing 2 times. Linear relationship. As the concentration of reactant increases, my rate is also increasing. So, it is first order with respect to A1. Sorry, A2. It is first order with respect to A2. A is the power of the order. As we linearly increase the concentration of A2, my rate is also increasing linearly. So it is first order with respect to A2. So it's not option A, it's not option B. It's either B or C. Okay. Now we need to compare species where A2 is constant. For example, let's say I take 1 and 3. 1 and 3. So among 1 and 3, 0.2 and 0.2, A2 is not changing. A2 is not changing, but what about B2? My B2 is increasing 2 times, 0.2 to 0.4. It is increasing 2 times, and my rate 1 and 3. My rate is also increasing 2 times, again a linear relationship, and hence B is equal to 1. Correct option is option B. Option B. Very easy. Next question is from the basics, question number 5. Rates of which among the following reactions can be measured easily? Now, this is where we begin our class of chemical kinetics, right? So we have AgNO3 plus Ki giving products. What type of reaction is this? AgNO3 plus Ki immediately forms AgI as the precipitate. And these conditions or this type of reactions are called precipitation reactions, which are very quick. Whatever principles that we are learning under normal kinetics, chemical kinetics cannot be used for reactions that are quick. It cannot be used for A, option A. What is option B? See, iron in the presence of oxygen and water is forming iron oxide. This is basically rust, and rusting of iron is very, very slow. It cannot be used for studying very slow reactions as well. Then what can chemical kinetics be used for? Chemical kinetics can be used only for reactions that proceed with a normal speed, a moderate speed, like formation of ammonia, which goes through moderate speed, and hence the correct option is option C. Option C. Next question. The figure represents the change in reactants and products in reaction with time. The reaction represented is very easy. So let's see. We can see that the graph of A is decreasing, and the species which decreases corresponds to the reactant. So of course, A is going to be the reactant, while B is increasing in concentration. The species with which increase in concentration corresponds to the formation of the products. But here B is on the reactant side, and hence A is not the correct option. So you have to cancel the options that is not correct. Okay, which will make you more confident. So A is the reactant. Now, what is the coefficient of A? Let's see. A starts from 4 and it attains equilibrium at 2. So it's changing from 4 to 2, and the difference is 2A. So the difference is going to be 2A because it starts from 2 and attains equilibrium near 2. Sorry, it starts from 4 and attains equilibrium at 2. So 4 minus 2 is 2. Okay, so it's not B is correct, C is correct, it's not D. That is also wrong. Now let's see it B. B is increasing from 0 to 1. Change is 1. Coefficient is also going to be 1. In both B and C, the coefficient is 1. While in C, it starts from 0 and attains equilibrium near 3. So the change is 3 units. And the formation of C will have a coefficient of 3, and hence the correct answer is option C. Question number 7. The question was asked in GATE. It's a graphical type question. Let's read the question. Decomposition of HA on gold surface shows zero order kinetics. Sorry. So what is decomposition of HI? HI, as we know, decomposes to H2 and I2. Okay. Initially, few moles of H2 are present in the container. Which graph is correct? 4 options are given. So it says that it's a zero order kinetics. We already know the kinetics of zero order reactions, right? What is the equation? The concentration at any time A is equal to the initial concentration minus KT. This is with respect to the reactant. Also, we have learned that the product formed, for example, if you have any reaction A giving P, initial concentration is A and 0, while at any time T, this is A minus X and this is X being formed. This was learned, correct? And during this, sorry, we also derived in our class that X is equal to KT. This much was known. Now see what is asked. It is asked that how is AT's pressure, not AT, how is hydrogen's pressure changing with time? So we know that the product pressure always increases. So it's not going to be A, it's not going to be D. The relation of the product and time is Y is equal to mx with a slope of K. And it is always going to be increasing. So it's either B or C. But which one? Now pay attention. If you look at this equation, it is just y is equal to mx and there is no intercept. And you might mark option C, but that is wrong. Why? Because in the question, they have already said that initially few moles of H2 are present. So already few moles of H2 were present and then it increases linearly. So the correct option is option B. Correct option is B. Okay. Okay, now let's move to the next question. Half-life, T half, and quarter life, T1 by 4, are represented by a zero order reaction. We need to match with 1 and 2. We need to match with 1 and 2. Okay. Very easy. We know the integrated rate equation for a zero order reaction, which is A naught minus KT. At KT half, the initial concentration won't change. Final concentration will be 50% of the initial, which is A naught by 2. Let's rearrange. I'll take KT half to the side. KT half is equal to A0 by 2 or T half is equal to A0 by 2K. Okay. Now, I need quarter life as well. What is quarter life? Quarter life is the time at which the initial concentration of the reactant is reduced to 25% of the initial value, which means the final value is going to be A0 by 4 equal to A naught minus KT1 by 4. KT1 by 4. If I rearrange, T1 by 4 is going to be equal to 3A naught by 4 by K. So if I look at the slope values, K is common in the denominators, but the numerical value is what is different. Here it is 0.5K and here it is 0.75K. So the slope of T1 by 4 is larger than T half. The slope of T1 by 4 is larger than T half, correct? Now we look into the graph. The slope of 1 is greater than 1 by 2. So 1 is going to be matching with T1 by 4 and 2 is going to be matching with T1 by 2. Okay? Yes, so that's it. Next question, they have said that calculate the T half for B, reactant B, in a second order reaction of A plus B giving P, giving that concentration of B is greater than A, already the integrated rate equation is given to you. You will get a general expression. It's going to be very easy. You have to find the T half for reactant B only. That's all. So let's try to rearrange. KT half is equal to 1 by B minus A. This is the initial concentration. That's not going to change. Is equal to ln of A into, this is where we put the final concentration, B minus X. We have learned in our class that B minus X is the amount of reactant which is left. And hence we will put our equation over here. We'll substitute the value of B by 2 over here divided by B minus A minus X, which is the final concentration. Correct. That's it. B and B gets cancelled. What you have is 1 by B minus A ln of A by 2 into A minus X is the equation. Understand that if you have any reaction A plus B giving equal to product, initially the concentrations are A, B and 0. Finally, the concentrations are A minus X and B minus X. So, in the question, what we have to do? We have to substitute for B minus X as B by 2. Because that is a question. We have to calculate the T half for B. So, T half for B means the concentration of B will become B by 2. Okay. Last question. So here a relation between ln T half and ln of the concentrations are represented for different order reactions. We have to find them. So now you already know from the previous question that for a zero order reaction, T half is equal to A naught by 2K. So if you have to write ln T half, it is going to be equal to ln A0 minus ln 2K. Okay, so this much you know. This is the T half of a zero order reaction. For a zero order reaction, if this is Y and this is X, you can see that this is a linear graph. This is going to be a linear graph. Okay. So see, its slope is positive. Positive slope. Mx, the value of m is 1 and it is positive. Let's say you have n is equal to 1. Order of the reaction, n is equal to 1. T half is equal to 0.693 by K. And we do know that T half has no dependence on the initial concentration. T half is independent of the initial concentration. And you can see a graph over here. Ln T half does not change with the value of ln initial concentration. It's straight. It does not depend at all. So this is going to be the kinetics for first order reaction. 2 is going to match with 1 for sure. So it's not option C, it's not option D. Okay. Now this has got a positive slope over here, n is equal to 0. Positive slope is represented by the first one. So this is going to be n is equal to 0. So that means the correct answer is option A. Let's look at the last one as well. So from the answer, we got it as second order reaction. Let's try it out. What is the integrated rate equation for second order reaction? It is 1 by A is equal to 1 by A naught minus KT. Now, if we have to substitute the values of A at T half, it's going to be equal to 2 by A naught minus 1 by A naught is equal to, oh, just a second, please, KT half. Okay. Now, if we rearrange this, we will get T half is equal to, oh, sorry, this is 1 minus A, 1 by A minus 1 by A naught equal to K. Yeah, like this. So this becomes 2 minus 1 is 1, 1 by A naught into K. So ln of T half is going to be equal to ln of 1 minus, or ln of 1 by K, let's write, minus ln A naught. So you can see that ln T half versus ln A naught has got a negative slope of minus 1, and hence the trace 3 corresponds to 2. Okay. Question number 11. The time required for the completion of zero order reaction is very easy. Come back to our equation. A is equal to A naught minus KT. At completion, this becomes 0 is equal to A naught minus KT, or time at which completion has attained is equal to A naught by K. A naught by K, option C. Question number 12. For a zero order reaction, initial concentration is 0.1. If 0.08 is after 10 minutes, then the half-life and completion times are respectively. So I would like to use the shortcut for this. You can even use the integrated rate equations, no problem. So let's say that I started with 0.1. It says that to reach 0.08, it takes 10 minutes. It takes 10 minutes. And we know that for a zero order reaction, equal time will reduce equal amounts of the reactant. That is, in the next 10 minutes, we have discussed this in class. This becomes 0.06. In the next 10 minutes, it becomes 0.04. In the next 10, it becomes 0.02. And finally, in the last 10 minutes, it becomes 0. Completed. So completion time is 10 plus 10 plus 10 plus 10 plus 10. Option B is the only one where 50 is there as the completion time. So completion time, T100% is equal to 50 minutes. And we also know that T half for a zero order reaction is equal to T100% by 2. We have derived the relation in the class. So that is going to be 50 by 2, 25 minutes, option B. Option B. Okay. Question number 13, very easy. What is the differential rate law expression for the given reaction? Easy. So first of all, in option A, which is a reactant which disappears, minus is not there, option A is wrong. For B, minus is still there, but then this is the rate of the reaction. We have to write the reciprocal of the coefficient. That is not there, so option B is also wrong. Last option, let's check. Minus 1 by 3 dA by dt is equal to dc by dt, okay, equal to ka to the power some number n into b to the power some number m. Yeah, option C. Next question. For the reaction, again a reaction is given. Volume is reduced to half its initial value by increasing the pressure on it. So when they say that volume is reduced in a gaseous system, of course, the pressure is going to increase. How much will the pressure increase? So if the volume is reduced by half, the pressure will increase 2 times. The total pressure is going to increase 2 times. Okay. If the reaction is of first order with respect to O2 and second order with respect to NO, the rate of the reaction will be very easy. Let's see. Rate of the reaction is equal to K into concentration of NO into concentration of O2. What is said? It is first order with respect to O2, which is 1, and second order with respect to NO. Correct? Now it is said that the total pressure is increased by 2. Correct? So this becomes K into 2NO and 2O2. This is a new rate. So what is a new rate? 2 to the power 2 is 4. 4 into 2 is 8. 8 times KNOO2. Or R prime is equal to 8 times the old rate, increased to 8 times its initial value. Option C. Option C. Okay. I think this is the last question. In the first order reaction, concentration of the reactant decreases from 0.8 to 0.4 in 15 minutes. The time taken from 0.1 to 0.025 is. Again, I would like to go with the shortcut. You can use the other way as well. So, it is said that 0.8 to 0.4 molar takes 15 minutes, which means 50% reduction. Correct? Again, in zero order reaction, as we did 2 questions before, it is same amount in same time. That is 0.02 molar in same time. It is same amount. Here it's not the same amount. It is the same percentages of the reactant in same time. Same percentage. So pay attention. One is percentage and the other one is just amount. So if I have to reduce from 0.1 to 0.025, 0.1 will reduce to 50%. That is 0.05 in the first 15 minutes. And then in the next 15 minutes, again, 50% of this value will be reduced, which is 0.025. Easy. You can do it using the integrated rate equations as well, but that is going to take a lot of time. This is, see, it's done within seconds. Option A. All right. So with that, we wind up our first session. I hope you understood the topics. If you have any queries, please feel free to reach out. Okay. So see you in the next. Thank you.